Shockwaves from a punch can do damage to the human body. Now we're going to time warp at 10,000 frames per second to see how sound waves destroy glass. Jamie Vendera is famous for using the sound of his voice to destroy wine glasses. They seem to simply explode. But what's happening?
I know the sound waves broke the glass, but I couldn't see how. So I'm going to use our slow motion camera to see what we were missing. Instead of singing, I'm going to use a speaker and a tone generator. I have to find the natural vibrating frequency of the glass. I have to match this tone. That's it.
This is the exact tone to make this particular glass vibrate. When the tone is loud enough, the glass will shatter.
I can feel the glass shaking, but I can't see it. If I add a straw, then it's more obvious.
So what's happening here? The straw gets tossed side to side, but I can't see why.
Let's record it while I crank the volume. I took 10,000 frames per second, and I took 1 second. If I were to play back this whole video, it would take 8 minutes to get through.
Oh, this is amazing. What felt like the whole goblet vibrating is actually the rim bending back and forth, 337 times a second, the same rate as the sound waves. If I draw in the sound waves, you can see what's happening. One wave comes out of the speaker and pushes the side of the wine glass. The glass bounces back just when another sound wave pushes it again. If the timing or frequency of the sound waves is exactly right, the motion will build until the glass breaks.
Wow. So, as we would expect, the speaker breaks the glass nearest to it. And immediately we see a crack that goes all the way around the whole bottom of the frame. I'm going to play that back again. This is where the initial fracture happens, right nearby the speaker. And in about 3 frames, and this is 3/10,000ths of a second, we see this crack go along the bottom where the glass gets thicker and come right back up to the top where it's thin. So if we follow that a little more, this piece has just fallen off, but it doesn't in some sense even know that it's fallen off from the rest of the glass. All of the glass was shaking at about 300 hertz, 300 vibrations per second. And this piece is still doing that. You can see the corners of the glass still flexing as if they were influenced by the speaker, but the speaker is way too far away now to have that influence on this piece. It just has the leftover inertia. And we see that in all the pieces here, even along the top edge of this glass. This piece of glass is not resonant at that frequency anymore, so it can't get energy from the speaker, and all that we see shaking is the leftover energy from what the speaker gave it in order for it to break.
So, if you thought that glass couldn't bend, think again. Time warping changes the way we see the world because it makes the invisible visible.